All right, so here's the situation as best I could draw it. Actually, that's not true. It's probably not the best I could draw it, but it is how I drew it. Okay, how are we going to tackle this problem?
Well, we need to figure out when it's up again. Well, maybe one way we could do it is see where it is where the arrow is for each tick on the clock.
Okay. Okay, that's an interesting strategy. What made you think of that?
Well, I was thinking it's down here. It's pointing down here.
Okay.
It's pointing up here. Where is it in between?
All right, that's a great question to ask.
Well, we could find what they're at 3 o'clock and 9 o'clock.
Well, it'll be the same for 3 and 9 because they're symmetrical. Where's the arrow pointing at 3 or 9?
Well, it's halfway between 3. It's halfway between 12 and 6. So it might have rolled a quarter around its circumference.
Which one? Which rolls a quarter?
3. If you're at 3,
So the small circle
rolls,
travels a quarter of the big circle circumference? That's what you're saying?
it travels a quarter of its. It travels half of its circumference.
What travels half of its circumference?
The small circle.
Ah, the small circle travels half of its circumference. Awesome. What does that mean?
Well, that would mean if it's traveled half of its circumference, it's starting here. Then the tangent point would be all the way up at the top, so it would be pointing inward.
Aha. Very good observation. Very good observation. So it's pointing inward.
So that's the point. That's would be.
Now you've made a statement that it should be symmetric on the other side.
So that means it should be pointing inward too.
All right, so why don't we check if that's true?
Well, here you can see you rotate halfway around the small circle circumference from here.
Okay.
So it means this point here is, not sure if that's on, but this point.
Oh, good thing to check. Wasn't on.
Alright, so
All right.
point here becomes this point here.
All right.
The arrow pointing toward that point.
So the arrow's pointing it. Cool. Okay, so we're off to a good start here. What do you want to do now?
We
Well,
could figure out how much rotates in between these, so we could figure out these intervals.
yeah, like how much it rotates between 12 and 1,
Okay.
1 and 2.
Well,
Well, I know that it rotates, well, we have the arrow going from straight up. I'll just pretend, I'll draw it in the middle, but I'll pretend it stays on the same center point.
Okay.
So it goes from here to here.
and well, it's going clockwise. The circle will rotate this way, so it'll be going around this way.
Yeah, it rotates this way.
And
Alright.
200. That's a 270-degree angle.
All right, awesome.
So that means
So this is 270.
we have to do 270 divided by 3
For what?
for the distance between these 6 and the angle it turns.
Okay.
270 divided by 3 is 90.
So it'll turn 90 between each interval here.
Okay.
So
It'll point straight this way. So
Why don't you, yeah. Okay,
Okay,
go
so
ahead. Just
first-
draw where the arrow, you don't have to draw the circle, just draw the arrow.
point this way. Then I'll point down. Then I'll point across. Up. This is at 4 o'clock.
Aha.
And then
and then it repeats itself.
Yeah. it repeats.
Okay, yeah, where's the next time it points straight up?
Looks like it'll be at 8 o'clock.
You made one little mistake there, see if you can find it.
Hmm.
let's see. You're down, in, just this. This is going this way.
There you go. 8 o'clock.
So you can see it's symmetrical
You have the points set.
because these occur at regular intervals.
They occur at 4 o'clock, 8 o'clock, and 12 o'clock.
Pretty cool. Alright, now I'm going to give you guys a challenge problem that we have not talked about today.
Okay.
Okay, so let's see how you do on this challenge problem, alright?
All right.
Okay.